All right, guys. I was just wanted to get something up online for you. Like I said, I won't be there tonight. A little hanging on day 4 of whatever it is. So bear with me and try to get through something. And if you hear a dog barking, it's my dog. So anyway, your book is this book that you're going to be using off and on throughout the semester by an author named Blitzer, one of Santa's reindeers. It's actually a very well written book. And chapter 1 is just an introduction to the sort of some vocabulary and language of mathematics. Um, and what we've been doing right now is up to now is pretty concrete stuff. What percentage of 25 is 5, or if I work 3 hours and Joe works 3 hours, and it takes 9 hours to do a job, how fast can we do it if we're working together? I'm just making stuff up right now in my semi-delusional state. But anyway, looking at algebra, it gets a little bit more interesting. You might look at something and see something written like that in a book, and you think, what the heck? Looks like hieroglyphics, right? X, you got some squiggly brackets, X line, some weird E and a Z. What the heck does that mean? Well, we're going to learn that stuff, and it's really not as bad as you might think at first glance. First of all, when we talk about algebra uses symbols for variables. In this expression here, um, it says 4x plus 6. Well, that's just an algebraic expression as you'd see it written. It means 4 times a number plus 6. X is called the variable. Now, what happens if we just say, okay, well, let x be equal to 2 in this case? How can we evaluate that? Well, we just put a 2 in where the x is. So in this case, 4 times 2 plus x is equal to 14. 4 times 2 is 8, plus 6 is equal to 14. And don't forget your order of operations. You do the multiplication first. Please excuse my dead Aunt Sally. And you remember we talked about that already. Now, in this case, we actually have an equation. Up here, 4x plus 6, that was just an expression, but that equal sign there makes it an equation. And we have constants involved. Those are the numbers, 6 and 10. And we have variables, or 6 and 12, and variables involved, x. We have a sum. That means we're adding things. We have a difference. It means we're subtracting things. Down here, let's say we have something that looks like this. 6x plus 1 is equal to 7. Well, we have some things going on here. We have a 6 in front of the x, and that means you multiply the x by 6. And the 1 is just a constant, and we're adding. 6 times a number plus 1 is equal to 7. Well, what would x have to be? 6 times some number plus 1 equals 7. In that case, well, x would have to be equal to 1. And we're going to learn ways to solve these. You can sometimes just solve them by inspection. I mean, you know that 6 plus 1 is 7, so x has to be 1. We also have quotients. X divided by 6, the quotient of x and 6. And that represents the operation of division. Your book goes in and talks a little bit about taking a sentence or a statement and translating it into a algebraic expression. And an example of this would be 7 less than 2 times a number. It's going to be your job to be able to translate that into an algebraic expression. 7 less than, that means I'm taking 7 away from some quantity. 7 less than 2 times a number. Excuse me. Well, 2 times a number is 2x. 2 times x. So 7 less than 2 times the number, 2x minus 7 would be our expression. Made a mistake when I was writing this earlier. The quotient of a number and 5 is increased by twice the number. The quotient of a number and 5, x over 5, is increased. that is signified by plus, by twice the number. And we have ourselves an algebraic expression. Not too bad at all. So it's important to understand what these things are saying to us, and equally as important for us to be able to come up with an expression given the English version of that mathematical expression. Now, when we evaluate expressions, algebraic, then we'll do what I just did earlier. Your book has an example, and they're showing on page 9, or excuse me, on page 3, a bar chart, and they're saying the average level of neuroticism versus age. I should just say something about when it says something versus something else. If ever we're looking at graphs, typically we have, I don't want that to be a picture. We have a setup like that. It's called a coordinate system. And this idea of something versus something else. Well, we have names for these things. We have the dependent variable versus the independent variable. And you always have the dependent variable on the y-axis and the independent variable on the x-axis. So let's say I had something like this. I wanted to say, how does plant height vary with grams of fertilizer? Well, the plant height is going to depend upon grams of fertilizer. And maybe you see something like this. Let's go back up here. Let's look at our graph. And this would be height, and this would be grams of fertilizer. And maybe with 0 grams of fertilizer, and let's say maybe up to 20 grams of fertilizer, and you're looking at one plant, you might see, some data that looks like this. You collect points, and maybe you see something that says, okay, wow, 10 grams, it seems to be going up, but maybe after 10 grams, maybe we're starting to do more harm than good. So we can draw some sort of a plot through that. And we're going to be doing quite a bit of that stuff as well. Again, nothing to be concerned with yet. And we could also draw graphs, XY graphs, such as in your book. It says neuroses and age. I'm just going to put neuroses and age here. And they're showing a bar graph. A bar graph is just another way to represent data. And it just shows us relative frequency of whatever you're studying versus the independent variable. Anyway, back to looking at evaluating algebraic expressions. They said that these neuroses on page 3 can be represented by an algebraic expression 23 minus 0.12x, where x is the age of the person. So if we use this as, we'll just call this n for neuroses. See, we're letting letters symbolize things. So this equation says your number of your level of neuroses is equal to 23 minus 0.12x. So if I say, okay, well, what what is your level if you happen to be 10 years old? Well, or let's make it let's make it I don't know 80 years old, like the book says. So, what's your level of neuroses at age 80 years old? 23 minus 0.12 times 80. And when you go ahead and evaluate that, you get 13.4. And what that number represents, it represents something that you're how neurotic you are according to the book. The goal here is just for you to get an idea of evaluating algebraic expressions. Okay, some more vocabulary here. They talk about looking in the second section here in chapter 1, talking about different types of numbers. Well, you might just think, well, what's a number? A number is 1, 2, 3, 4, 5, negative 10, 6. But mathematicians and mathematics people classify numbers according to their properties. First of all, and I put a video up by, I believe, an Indian gentleman who explains this beautifully. We have the set of real numbers. Okay, guys, I'm about to make a mistake when I was recording the video. I referred to the set of natural numbers as the set of real numbers. So I wanted to point that out. The set of real numbers are all numbers that we'll talk about. Real numbers include the integers, it includes the natural numbers, it includes whole numbers, rational numbers, but the set of real numbers do not include imaginary numbers, which we probably won't talk about in this class. So that's a little correction. It's symbolized by capital R, the real numbers, and those are just your regular 1, 2, 3, 4, all the way up forever and ever. Those are the real numbers. And what you're seeing here are these brackets are a way for us to indicate something called a set. A set. A set is just like let's say I had let's say I'm trying to come up with a set, and I say, okay, I want the set of even numbers. Well, the set of even numbers, between 0 and 11. Well, your set, let's just call this set S. We'll just give it a name. Oh, that's supposed to be a bracket. We can just write it like this. Well, I've got 2, I've got 4, and I've got 6, 8, and 10. And then I close it with a bracket. All that bracket, or the so-called roster notation, it's just saying, hey, my set is going to be enclosed by these brackets. Well, the set of real numbers the set of real numbers contains, I should say, 1, 2, 3, 4, all the way up until you are done counting or you die. And you can never be done counting because it goes to infinity. Now, there's a symbol you're going to see that looks like this. That means is an element of. So, is 4 an element of our set S? In other words, is 4 contained in those brackets? Yes, 4 is an element of our set S. And that's all. When you read your book and you see that symbol, that's all that symbol's telling you. Okay, so we've got natural numbers, or also real numbers. And we've got the set of whole numbers. And that's the set of natural numbers. I misspoke up here. This is the set of natural numbers. Real numbers is a much larger set. The set of whole numbers, they just contain the same as the set of natural numbers, but they contain 0. 0, 1, 2, 3, 4, ... That means keep on going all the way up to infinity. So natural numbers are 1, 2, 3, 4, so-called counting numbers. Whole numbers contain 0. Integers, and these are all real numbers, by the way. Integers, that's given a fancy Z symbol. And that's going to be -3, or let me. It's a set of whole numbers including negative numbers. So ... -3, -2, -1, 0, 1, 2, 3, ... So those are the integers. Okay. So we've got the natural numbers, which I misspoke earlier, called them real numbers, whole numbers, integers, and then finally we have the so-called rational numbers. Rational numbers. And the rational numbers contain also numbers that can be represented as fractions, a over b. So we could have numbers such as 1/2, 3/2, even 4/2. Well, 4/2 is 2, but it can be represented as a ratio. Okay. So when you read through that, again, don't get too panicky about that. There are also things called irrational numbers. And irrational numbers are numbers that just go on forever and ever and ever. The decimals never terminate. So you can have the square root of 3. Or if you plug that in your calculator, you're going to get 1.7 blah 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 blah, and that number will go on forever. The number pi, 3.141 ... That number goes on forever. Those are irrational numbers. So when you read about that, don't get scared about irrational numbers. Now back to real numbers. Real numbers. Real numbers are all numbers that are not imaginary. So we have all kind of numbers. So in the way we represent this in what's called set builder notation, real numbers are all numbers x such that x is rational or irrational. So those are all real numbers. So pi is a real number. 1/2 is a real number. 0 is a real number. And these brackets, the way you read this says the set x such that x is whatever. Could be an odd number, an even number. Just don't be frightened by the notation. And that's kind of sloppy. This should be a bracket. But eventually they just end up looking like squiggles because people get lazy with them. So I'll let you read through the chapter. The remainder of it talks about ordering the real numbers using the number line. And the number line you know by now. 1, 2, 3, 4, all the way 5, -1, -2, -3, -4, and going infinitely in either direction. And we can use this to sort of just say, where can we place our numbers on this number line? Well, our number line, let's say I have the number 2 and I wanted to plot that. I would just put a big old dot on 2. And if I place a number to the right of that, like say 5, we could see that 5 is farther along in the positive direction on the number line. So we'd say 5 is greater than 2, and that symbol means greater than. Also, we could say 2 is less than 5. So that symbol, greater than and less than. I think you've seen that. And they do some plotting of stuff on the number line. Example 6 uses some inequality symbols. And finally, the book talks a little bit about a notation. So if I say, plot on the number line let me see, plot on the number line whole numbers greater than 2 and less than 5. Well, you have to be careful because they don't want you to plot a 2 or the 5. They just want us to plot the values on the number line that are greater than 2 and less than 5. So then we'd only be looking at 1, 2, 3, 4, 5. These values here, 2, 3, and 4. Now, if we were talking about all values, say all values of x such that x, let's rewrite it this way. All values, not just whole numbers, this sentence tells us something a little bit different. This wants us to plot all values that between 2 and 5, but not including 2 and 5. So that would mean 2.1, 2.2, 2.3, 3.7, etc. The way we'd plot that on the number line, 0, 1, 2, 3, 4, 5. Then what we would do here is we draw an open circle at 2, 3, 4, and at 5. That means those points are not included, but I wish I had a different color of pen. I wonder if I can get a different color. Oh, looks like I can. Oh, I was trying to get red here. Let's go like that. And then we'd have to just shade that whole region in. That would mean that we're plotting all of those numbers on that number line. So I encourage you to go through. Oh, by the way, let me show you some interval notation before we wrap this up. And I apologize for being a little bit on the scatterbrain side tonight. Let's go back to my black pen. Oh, there we go. Now there is a way to represent this. And so if you're reading along and you look at page 11, we have notation that looks like this, oop, like this, and I'll explain what all these mean. Like this, and then some ones with infinity that we'll go into later. But what this means, it means the round parentheses means that these endpoints are not included. So this is a type of an interval that's an open interval, like I showed you above. I included all the numbers between 2 and 5, but not 2 and 5. If you saw the brackets, that would mean, let's go back up here, that would mean I'd have to include those points. Now, A to B, excuse me, let me go 2 to 5. 2 to 5. That would mean that I would not include 2, not include that, but I would include 5. So I'd have a deal like this. I'd have at 2, I'd have an open, and at 5, I'd have a closed dot, meaning that's included, and all the numbers between would be shaded. So likewise down here, if I have a 2 with a bracket and a 5 with parentheses, it means that 5 would have the open dot, and 2 would have the closed dot, and we'd shade everything in between. All right, so take the time to read that. As far as homework goes, you have plenty to do already, but I'd look at practice exercises on page 12 and maybe pick out 3 or 4 from the first part. From each section, maybe pick out 1 or 2, and then I'll formalize this more when I see you next week. So take care and see you then.